We're going to be going through some slides today, and I'm also going to do some live demonstration. Before we really get into the details of how to shift left, it's going to be important to sort of set the stage a bit for the whole problem space of cloud configuration and so on. So we're going to do a little bit of that. But first, a little about me. My name's Josh Stella. I founded, along with some colleagues, Fugue a few years ago. Prior to that, I was a principal solutions architect with AWS, focused on national security. And I think I have a slightly unusual perspective in that I've spent my career bouncing back and forth between startups and national security kinds of application development and so on. And Fugue really incorporates both those things, the ability to go fast, how you want to do as a startup or doing digital transformation in an enterprise, but doing it really safely and well. And that's where my national security background, and a lot of us here, comes in. Joining me today is Ricardo Green, our principal solutions architect, who's going to help me with some Q&A at the end. So again, we're going to go through some slides. I'm going to show some demo, and then we'll take your questions. And feel free to ask questions along the way. We're going to gather them up for some Q&A at the end. So you're going to see me refer to a number of statistics, whether it's percentages, the 93% on this page, or other statistics through here. These are from a significant survey we did of over 300 organizations who are operating at scale on cloud. So where I'm using these stats, I'll call them out. But this one is about cloud misconfiguration and that it is a big security risk. 93% of our respondents are concerned that a major security breach will happen due to cloud misconfiguration. And Gartner has actually said that somewhere between 80 and 90% of all cloud security breaches will be due to misconfiguration of cloud resources in the next few years. So that 93% is right to be concerned with this. After we did this survey, we published some of the research, and David Linthicum of InfoWorld wrote a small story about it, an article about it, and this quote is from there: "The complexities of cloud computing and the chance of human error will bite you in the butt." That is true. I've been doing cloud for a decade now. I've made lots of errors, and I spend a lot of my time focused, again, on correctness. So I might change the word chance in this quote to the inevitability of human error. It's just too complex for humans to handle, and that's no one's fault. That's because the cloud is feature-rich, because it can do many things. But it does mean you've got a problem space to deal with here that is very much non-trivial and with very real risks. So these are all, when you make that error, which you're going to, if you're unlucky, you end up in the news. If you're a little more lucky, maybe somebody discovers it in-house. But these are very significant breaches due to very small errors. Some folks like to point the finger at the cloud service providers and say, well, they don't have secure services. That's not true. None of these breaches were due to actual breaches of Amazon or other cloud providers. They're very good at security. These are due to misconfiguration by the customer of the resources on the cloud. And so often the finger kind of then points at the customer. Oh, they didn't know what they were doing. Actually, it's really hard to keep track of as many configuration items as you need to on cloud to get things right. Almost impossibly difficult manually. And so what we're going to be talking about is how to get security and compliance into the DevOps tool chain early to avoid these kinds of errors before they ever happen. So the cloud creates new security challenges. If you come from a traditional security background, you've probably spent a lot of your time on things like perimeter defense and network traffic, identification of threats and endpoint monitoring and things like this. Well, in the cloud, your biggest vulnerability surface, the biggest attack surface for the bad guys, and the biggest misconfiguration potential for your team is getting these cloud service APIs misconfigured. So let's talk a little bit about what these cloud service APIs are. In the cloud, all of your infrastructure is created and controlled via application programming interfaces, via APIs. And so what that gives you is the ability to summon up a network in 30 seconds, or change a firewall setting with 2 clicks. And this is a wonderful thing because it allows your developers to really innovate fast. They're no longer having to go through change control boards and wait for a database connection to appear. They can just do it. But that also means you're now dealing with a much more dynamic environment. So the APIs giveth and they taketh away. What they give is the ability for your organization, this is the principal benefit of moving to the cloud, to iterate very, very quickly, to innovate, to experiment, to try things. But what that exposes you to are new kinds of risk and a lot more change in the infrastructure, any one of which can introduce risk. So how do we reduce risk and keep that dynamism? So kind of multiplying this problem are all the new services and operational patterns that the cloud are bringing out. So a few years ago, when we were talking about cloud, we were really talking about kind of data center-like objects, you know, servers in the form of EC2 instances and databases that were long-lived, and using network ECLs to control access, and security groups, which are like firewalls. And then containers came out, and that changed the threat surface, that changed the vulnerability surface. And then serverless computing came out with Lambda functions. And now, as these new services come out, that means security has to be aware of whole new ways of thinking about attack surface, right? With Lambda functions, for example, most of that is not at the TCP/IP layer, it's at the identity and access management layer in cloud. And so the combination of these things, especially when you adopt at scale, lead to a lot of challenges. How can you know if things are in compliance and secure? And then how can you maintain that things are in compliance and secure while moving fast at scale, while not getting in the way of developers? And the answer to that is to shift left with tools like Fugue, which we'll drill into more. So let's talk a little bit about the most common types of cloud infrastructure policy violations. This is, again, data from our survey. So 66% of respondents said identity and access management rules are a problem. And this is because they're very complex and they are very powerful. So it's easy to get them wrong, it's hard to get them right. And if you get them wrong, you have big problems like those S3 buckets that were compromised in the earlier slide. Number 2 on the list, security group rules. These are effectively firewall rules. Number 3 on the list, object storage access policies. Again, those S3 bucket access policies. And then number 4 on the list, encryption and transit disabled. These are easy things to get wrong, and that's why they scored high. Like IAM is incredibly hard to understand. As one of the people who, you know, I used to work at AWS and we would talk about it internally. It's really hard to get your head around because it's so powerful. So these are the main areas where folks are seeing policy violations. I'm going to take a slight detour here and talk about the shared responsibility model of cloud to point out some things you may not have thought too much about around where your responsibilities lie and where the cloud service providers begins. So at the bottom, the green boxes from networking, storage, servers, virtualization, these are the things the cloud service provider takes care of for you. This is their responsibility, not letting bad actors onto the data floor, making sure the underlying physical infrastructure is configured the correct way and is operational. But all the purple stuff is your job, starting with cloud configuration. And as I mentioned earlier, Gartner says cloud configuration is actually the #1 place where you might run into problems and security breaches on cloud. But you've probably, if you're using traditional tools and you're going from the data center to the cloud, you're probably thinking more about your data, your application runtime, and OS, the more traditional pieces of infrastructure and configuration that you've had to worry about from a security perspective. So what's causing all of this cloud misconfiguration? According to our survey, 64% said it was human error. But I'll point out that the other two big contenders here, lack of team awareness of security and policies, and lack of adequate control and oversight, are just other forms of human error. So there's a theme here, which is that humans are not able to keep track of cloud configuration and keep it in policy and keep it under oversight. And there's a good reason for that. It's not humans' fault. We're not great at keeping track of lots and lots of details. So if you go to that middle column there, lack of team awareness of security and policies, and you look at that list, HIPAA, PCI, NIST 800-53, GDPR, SOC 2, CIS, ISO 27001, NIST alone, these are compliance standards. So these are collections of rules on how to do security and compliance on cloud and other places. NIST alone is over 1,800 rules. So expecting people to be aware of these policies is like expecting them to memorize a phone book. I'm probably dating myself, I remember phone books. I may be aware that the phone book is there, but if you ask me any given a person's name, I'm not going to be able to tell you their number without looking it up. These are very complex environments. So the notion that we can fix this by making humans more aware is just wrong. It's not going to work. And the same is true for lack of adequate control and oversight. Most control and oversight is done after the fact instead of up front. It's shifted right instead of shifted left, and is often done manually. That is an impossible task. And because of those kind of stresses, this pits teams against each other. Right? DevOps and application business units, development business units, are really being pressured to move fast, to do new things, to drive new business, to digitally transform their enterprise. Their job is to create growth, where compliance and security teams, their job is to keep things safe. In the traditional model, where security and compliance are way on the right-hand side of the software development lifecycle, that just sets up an adversarial relationship, where security and compliance are coming in towards the end and saying, no, you can't do that, or they're making changes in production runtimes that break systems or confuse DevOps. So the answer to this is to pull these folks together by shifting left with security and compliance. Now, we see this all the time, that the reaction from security to the new world of cloud is to try to make it look like the data center, is to restrict access and innovation, to clamp down on what DevOps is capable of in order to keep things safe. And the way they do this often is through manual certifications and approvals, approval steps along the way where humans review things and get in the way of deployment. Very often, I've had people proudly tell me they're locking down the cloud console. Nobody can access the cloud console. And I think to myself, I understand why you're doing this. Because developers, I'm a developer, we do kind of crazy stuff, but we're doing it to learn and innovate. And so if you take away that capability of cloud, that principal benefit of cloud over the data center, by saying, no, we're just not going to let you access this, we're going to put guardrails up, and we're going to take away your console access, well, your competitors who are letting their developers be more creative are going to win, because you're taking away access to the principal benefit of the cloud. So I understand why people do this, but it really throws us back. It's a very anachronistic approach. So a little stage setting for what we mean by shifting left. What are we shifting left on? It's the software development lifecycle. And this is one representation of it. We've drawn it as a line. Some of you out there might be saying, hey, this isn't a circle, it's not agile, it's waterfall. It's just easier to show this way. You start out by gathering some requirements. You decide kind of roughly what you want to do. You go into a design phase, you start developing, you go into test, and as we all know, there are multiple stages of test. Then you deploy, and then you review. In any agile methodology like we use at Fugue, the arrow to the right of review points right back at design and maybe to requirements. And the whole thing iterates, often very quickly. At Fugue, we do it every 2 weeks. So as you're on the left-hand side, things are less set in stone. And you've invested less time, effort, and money into them. And so change to the left is easier, faster, and less expensive. As you go to the right, you're accumulating cost and time that you've sunk into something. So change as you get to the right might set this whole cycle back. It's more difficult, it takes longer, it's more expensive. So security and compliance generally have happened way to the right, after development and often at the tail end of test and to deploy, but often with things like scripts and bots, security scripts and bots, they happen post-deploy, which is really bad. So they're happening to the right either as a gating function, which might cause development to recommence to fix things, or they might actually do harmful things to the deployed environment for the operations. So what we want to do is shift left so that security and compliance, so corrections to the system happen sooner, preferably within minutes. The developers get feedback as to whether what they intend to do is going to be allowed, and that makes corrections easier and faster. So shift left is a term that's kind of gained a fair amount of popularity. You might have seen it thrown around. Usually it refers to the OS runtime application and data, and the same with the term DevSecOps. Usually these things are referring to the sort of traditional parts of the system that we think of as application development. Well, there's this new thing, relatively new, cloud configuration, which sits right between operations, security, and application development. And this is where we're going to focus, because this is the hardest thing to get your hands around. We're going to introduce a new concept here called a baseline. And you've heard the term before, but it's important to understand for the purpose of this presentation what we mean by baseline. In our world, in Fugue's world, it's a contract between cloud stakeholders. And I mean this in the formal kind of computer science and programming definition. I'm not talking about something that's in writing on a shelf in English. I'm talking about something that a machine can act upon. Something that is a complete picture of cloud infrastructure and how everything is configured. A survey of everything that exists in that cloud infrastructure. And once you have that, you can come to agreement between these stakeholders. It can serve as a contract between development, operations, security, and compliance. Development can say, these are the technologies we want to use that we've deployed. This is how the system should be architected and work. Operations can say, yes, this is going to be high resiliency, this meets our requirements. And security and compliance can say, this meets policy, and we agree to it. And what that does, by creating a single source of trust and truth, right? The truth being that contract. We've all agreed that this is how the system should be. And again, not on paper, not a Visio diagram, but the actual configuration. Then we can shift left on security and compliance. So I'm briefly going to talk about another approach that's becoming common that I think is fraught with both risk and can never be complete. And that is auto remediation in the runtime. This is really talking about the right-hand side, not the left-hand side. It's talking about post-deployment of the application using scripts and bots to go look around to see if anything dangerous has happened and to try to fix it. We really don't like this approach. We take a very different approach, but I want to talk about this for a moment because you're probably starting to hear about this. So the first thing you have to do to use automation scripts or bots or Lambda scripts for this is write the code. Now you might go find, as I have done, on GitHub repositories of these bots. I won't put a URL up because I'm not going to jump around, but I found one on GitHub that had about 35 different bots. One of them was just there for adding VPC flow logs to a VPC that did not as yet have flow logs. So one very specific configuration item, it was about 320 lines of code. So as you imagine trying to really be complete with automation scripts, you have to predict anything that might ever go wrong. And you're going to fail at that. But even for the things you succeed at, even for the things you do predict, you're now maintaining code. And you're going to have a significant amount of code. So first you have to write all that code. Then once you're deployed, you need to use a scanning tool that finds a misconfiguration and triggers the automated remediation. So it's really the automated remediation action without a baseline that's a huge problem with this. There are many problems with it, but that is a particularly ugly problem. I was talking to a friend of mine at a large financial services company, and he said, yeah, our security team put bots in, and it blew up some of our production servers because they misidentified them as security holes and unused resources. So that happened because there was no single source of truth. There was no baseline that everyone had agreed to. So this approach is both incomplete because you have to make predictions and write blacklists of everything that can go wrong. And it also misses a lot of things. So you end up with alert fatigue, and it can be very dangerous because if those scripts are imperfect, which they will be, they're not all that contextually aware, they can often cause problems in the operational infrastructure. From the correct. We're going to use automation around keeping things correct, and we're going to provide automation that gives guidance on how to be correct early in the life cycle to the left. So that allows that shifting left on compliance. So this idea of baselining really drives DevSecOps and cloud security. That it drives the intersection of these things. On the DevSecOps side, and the shift left side, you need to establish a known good baseline. Well, a key component of that is how do you know it's good? And we're going to show that in a little while. How to let developers know what they're doing is correct in a very easy to use, developer-friendly, automated way. You do that with policy as code. You do it with CI/CD integration, so that as developers work in their natural life cycle, they're automatically getting feedback as to whether what they're building is going to be acceptable in production. So that takes care of the left side of the SDLC. But once you get out into deployment, you now have this kind of magical ability, which is you know what good is, and so you can enforce the known good baseline. You no longer have bots that are trying to make arbitrary decisions about whether or not something should be the way it is or how it should change it. You can just revert to the known good baseline. And that's really what Fugue was designed to do, which we'll show you soon. So this bridges the divide. This gets everyone on the same page. The compliance and security teams can now come bearing gifts to the dev and infrastructure teams, those gifts being tooling that will tell developers and ops folks all the way through the process whether what they're doing meets policy or not. So instead of having to memorize the phone book, you're automatically looking up the numbers for them along the way. Maybe that's a bit of a strained analogy, but you're automatically giving them that feedback. You're not asking them to do something unreasonable. And so it gets everyone on the same page, and then developers and operations teams, DevOps teams, can trust the security teams to automate automation once it's deployed because everyone has agreed. So where to start? There are 3 places you can start, and you can kind of do these all at the same time. Often people start on the left and kind of go to the right, but you can parallel track these two. So if you're here at this webinar and you're interested in this topic, you probably have brownfield deployment in cloud. You probably have things you've already made. So the first thing to do, perhaps, is choose your policies. And if you're in a regulated industry or you spend a lot of time thinking about it, you might know what your policies are. But if you don't, that's fine. There are a set of policies out there that Fugue comes with in the box called CIS Benchmark that will give you a really good start on how to do cloud well and securely. But what you need to do is go look at what you've already made and find out if you've gotten it right or not. And where you identify violations, work with the developers to go back and fix those issues. So for your brownfield stuff, you can get started with Fugue in about a half an hour, just looking at these environments and saying, okay, where are we getting it right? Where are we getting it wrong? And come up with a plan for changing those things to move them to a known good state. So the middle column is really about integrating, if you're in security and compliance, integrating with what your DevOps team are doing. And this involves going and talking to them and saying, what are your CI/CD tools? Are you using Jenkins? Are you using GitLab? What are you using there? How can we integrate with it? Because that's what you need to do to shift left. You need to integrate with their workflows. And we'll show you some of how to do that. Find out what they're using, if anything, for infrastructure as code. You know, is it Terraform or CloudFormation or Ansible, or are people going to the console and clicking around? Is it a mix? Very often a mix, which means you probably can't use infrastructure as code as a place to check policy. So you need to do it during the development lifecycle. You need to integrate those policy checks into the tool chain, including your security best practices. And then as you mature, you can start to establish baselines. You can identify them as critical cloud resources and establish those baselines. And these are the baselines I was talking about before, the exact configuration of that collection of infrastructure. You might want to start with things that have particularly sensitive data or that are really problematic services from a drift perspective, like access controls, IAM. Then you want to monitor for drift. One of the beautiful things about baselines is you're no longer monitoring or scanning for anything that smells funny. You're monitoring for things that deviate from known good. And then as you really start to mature, and we've seen folks go through this whole kind of life cycle in a matter of weeks, you can start to enforce those baselines in an automated way. All right, I'm going to switch over to do some demonstration. So what I'm showing you here is a collection of what we call cloud environments. So what Fugue means by an environment is a collection of infrastructure that you determine. You set the scope of that environment, that collection of infrastructure, and also what rules apply to it, both policy and compliance rules, but also things like baselining and drift detection and enforcement rules. And those can all be set differently, as well as different scan intervals and so on. So I have a number of environments here, all pointed at my AWS accounts. The first one is really configured to work with the development teams. And so we've called it App Team Development. Let's take a look inside of here. So you can see I have a collection of resources, 21 different types of cloud resources. So one of the things we believe at Fugue is you really have to be able to drill deep into the cloud infrastructure. You can't just look at security groups or things like that. We've got 68 resources here, 4 of which are breaking some CIS rules. So I'm showing this to you in a graphic user interface. We also have it available via API for integration with existing CI/CD tool chains and the like. But I'm going to pretend I'm a developer working at the console. And let's say I go in here and I want to add a security group. Oops. So I'm going to create a security group. And I'm a developer, so I'm confident, so I'm going to call it Josh Safe Security Group 1. Say this is definitely safe. I'm going to assign it to this VPC, and I'm going to create it. Let's find it, this guy. And I'm going to create some ingress rules. Now, I'm in development mode, so I'm thinking, well, I'm a developer. I need to be able to access things. I'm just going to say all TCP, and I don't really know where I'm going to be working from, so I'm just going to open it to the world. I'm going to switch. This, by the way, is the AWS console. This is not part of Fugue. If you're unfamiliar with it, this is AWS's graphic user interface. I'm going to switch back over to Fugue. We can see here, I have this set to rescan every 30 minutes. Well, we're doing a demo here. I don't want to wait 30 minutes. So I'm going to show you another aspect of Fugue, which is our API, because if I were a developer doing this through a CI/CD toolchain, I probably wouldn't be clicking around in the console. I probably would have defined that in Terraform or CloudFormation and fired off that change to the environment through the CI/CD toolchain. So remember, I'm pointing at the development environment. I'm making changes using my standard tools. The screen I just brought up is a little REST API tool called Postman. This is not part of Fugue, but this API on the left is Fugue's API. And so you can see here we can get lists for all environments. Well, let's take a look at all our environments because I want to trigger a new scan on that app team development environment. I can find this right here. This would all be automated in your Jenkins or whatever your CI/CD toolchain is, where when that change was made, part of the process would be firing off automatically a new scan. So I just showed this through Postman, but this would all be behind the scenes in your CI/CD toolchain. And as I come back here, you can see now there's a scan in progress. So this environment has now been triggered to scan again. And I'm going to come back to this in a couple of minutes when it's done to show you that the developer will now get feedback and talk about how that could be integrated into the CI/CD toolchain. So what about compliance folks that want to shift left and see what's going on and be part of the loop without having to go through audits? Well, this view of Fugue, what we've done here is we've collected up over 600 resources, and we're comparing them to CIS and NIST. If you're not familiar, NIST is NIST 800-53. It is what the federal government and many regulated industries use. And I can look at it by resource type and see, oh, look, I have a DynamoDB table that somebody's built that is not compliant. So when we talked earlier about going and looking at your brownfield and saying what's wrong, in this case, this DynamoDB table does not have encryption turned on. And so not only does it tell you which resource to go fix, it tells you which compliance rule failed, and it tells you how to go fix it, which is to turn on encryption. So in the compliance view of the world, you can have this constant monitoring. In this case, we're doing it daily for the compliance and security teams. You can also receive a daily or weekly automated report of this to just keep track of what's going on out there. But it's an amazing discovery tool for going out and finding what is compliant and non-compliant in your environment. So I've showed two of these environments, the app team development and the US WestQ daily compliance. If you notice, in neither of these established baselines, and a lot of my presentation was about baselines. The reason I haven't established baselines in these is because these are really discovery use cases for Fugue. And we can see here, app team development got done, and now I went to 5 non-compliant resources instead of 4. And I can see here, port 22 and 3389 are open. Well, that's because I opened that thing to the world. And the really nice thing here is I can now say, okay, that's the security group that's the problem. I can go find that guy, and I can modify it. And what I might do here is instead of having all TCP, I might open just, let's just delete these and say, well, what I really needed was HTTPS. So I'm going to be a little more disciplined about how I build this. And so in this way, we've shifted left. The compliance and security teams have provided tooling to developers that integrates with the CI/CD toolchain so that as I'm developing, I can see when I do something wrong and I can go fix it without having to wait for an audit at the end of the process. Now let's talk about once we have that baseline, there are really 2 use cases we can serve. One is where we constantly detect any changes from the baseline, but we don't do anything about them. We just alert people to them. So in this environment, I have drift detection turned on. Same roughly 630 some resources. I'm not using compliance families. I'm just checking against the baseline. And by doing that, and by the way, to establish a baseline is as easy as clicking this button here or hitting a single API call. You'll notice I'm not enforcing the baseline. I'm not doing self-healing. I'm just doing alerting. But I can get a log here of everything that changes over time. And this is a really powerful way. This is my security group I just made. You see it picked it up. It said Josh Supersafe SG. Said, hey, that's drift. Something changed out there. I added a S3 bucket a little while ago. I picked that up. So this is a way to use Fugue where your security and your DevOps teams and compliance teams can all see what's happening based on that single source of truth of the baseline. So any of those drifts are deviations from that. And if you choose to, you can just turn on baselining and then generate a ticket from that to go look at it or what have you. But next is the most powerful aspect of Fugue for the runtime environment, and that is self-healing or baseline enforcement. And so in this model, I'm looking at the environment every 10 minutes, and if I see drift, I'm going to fix it. Fugue is going to automatically fix it. So again, zero code. Let's go back into AWS console here, and let's just start breaking things. Let's go into security groups. Now, when I showed you this before, I was making a new security group that broke the rules, and Fugue told me I was breaking the rules. This time, I'm going to take an existing production security group. I'm going to destroy the legitimate ingress ports. In other words, I just broke my application. And I'm going to open SSH to the world. So I've just done two things there. One, I broke the application, and two, I opened a big security hole. But let's jump over from EC2 to VPC, to Virtual Private Cloud Networks. And let's delete some tags. If you've used AWS much, you're probably using tags to keep track of resources. And it's probably a bit of a nightmare when things aren't tagged. So I'm just going to show you how easy it is to just remove those tags that we're keeping track of those resources for me. So now I have an orphaned network. I don't know who owns it. The tags are gone. So with automated remediation scripts, in order to have any effect on these, I would have to have some automated remediation script that was keeping track of every tag on every object in AWS and making sure it stayed the same. I would have to be looking for any changes to the environment, including non-security infractions. So for example, removing HTTP and HTTPS, that broke the application, but a security scanner is not going to pick that up. Not having HTTP and HTTPS is not a security infraction. So some other tool is going to have to notice that. So I just jumped back over to Postman to tell that environment. It's set on a 10-minute loop, but I don't want to wait 10 minutes because we're doing a demo. So I wanted to come here and tell this environment, go ahead and update now. So it's going ahead and doing a scan on that environment. So in this one, we have baseline enforcement enabled. And just as establishing a baseline is as easy as clicking this button or hitting a single API call, similarly, baseline enforcement is just checking a box. While that's running, I want to show you a little more about Fugue that differentiates us from many others. Our service coverage and depth of service in the cloud is much, much deeper than just security tools, scanning tools have. So we go really deep, and that allows us to find things that are pretty sophisticated problems. And by sophisticated problem, I mean something like this. So here we have a CIS fail. We show you the rule. The description says, ensure that IAM password policy requires at least one uppercase letter. But what we detected was that there was no policy document found. So what this means is for an IAM policy to be able to set a requirement for an uppercase letter, there needs to be a policy document. Well, many tools won't find that, but Fugue will, because we totally understand that IAM password policy and all the attendant services to it, which is also why we can do full automated self-healing with no code. So it looks like that scan ran. Let's go take a look from our baseline here. This is how things are supposed to be. We'll go back to the drift events tab. And at 142, we picked up a couple of drifts. Let's look at what those are. So this guy, this security group, was modified. It had 2 ingress rules. On the left is what the baseline says it should be. Port 80 open, port 443 open. So that's HTTP, HTTPS. And that was drifted to only having one thing open, which was port 22, SSH, a big security hole. But let's also look at this VPC change. So a security scanning tool would not notice this typically because it doesn't keep track of all the tags. But because Fugue knows in the baseline, we have a single source of truth. This is how it should be. And all stakeholders are represented in there. It's not just security, it's DevOps, it's compliance, it's app devs. So in this case, this resource is supposed to have 2 tags, and they're gone. So let's see what Fugue did. And it looks like all this happened within 1 minute. So Fugue reverted it. We took away port 22, we put back HTTP and HTTPS. So unlike a security bot tool, we've healed infrastructure from an operational perspective here. We haven't just closed a security hole, we fixed functionality. And we also closed the security hole. And guess what? We keep track of all of the tags and the state of them, and so we've replaced them. And so that's self-healing infrastructure from baselines. And that's how you shift left with security and compliance in the cloud. And I'm going to pause there and ask Ricardo, did we get any questions? I'd like to go to some Q&A.
Yes, we absolutely have a couple of questions, and I'm actually going to, they kind of blend together, so I'm going to kind of take liberties and reword it. So the question is kind of twofold. One, how are we able to assess Terraform or CloudFormation prior to deployment? And the second one is, where in the pipeline are we actually doing this? If you could talk about those 2 things, that would be great.
Sure thing. So if you're talking about analysis of code from Terraform and CloudFormation, you're never going to get a complete picture because of the nature of those tools and the language they use, the languages they use. Put another way, if you think about doing a Terraform apply where you're pulling data from data sources that are dynamic in the runtime, you're actually not going to know the final state of the infrastructure until it's been run. And the same is true with CloudFormation. And so this is why when you go to the AWS console and you ask it to validate your CloudFormation template, it says, yes, this looks good, and then it fails and rolls back, it's because that language is very difficult to do things like deep static analysis on. So the approach, I will say a caveat there, is we are looking at exploring that at Fugue for those languages, Terraform first, but there are severe limitations, I would say, or at least significant limitations. So the way we recommend you do this is in the development environment, the post-deployment development environment. The other problem with trying to analyze source code, other than you're never going to get it right, because you have to kind of create a simulator or something like this, is you probably have in your organization a mix of different provisioning tools, whether you know it or not. Even if you have a policy that says thou shalt use CloudFormation, there's probably something out there that was built at the console, that was built using Bodo scripts, that was built using Terraform, and that's not going to help you. So it's much more powerful to go from an actual deployed environment where we can know everything about it. The first place you can do that is in the development environment. So our recommendation, and this is what our customers do, is as in this app team development environment, as part of your standard CI/CD process, as you're deploying with Terraform or CloudFormation or Ansible or Bodo or whatever, have it trigger the CI/CD tool chain to call Fugue to give you that feedback. And I showed this in a GUI, but this same stuff can be shown in an actual API return. This again is Postman, it's a tool, but this would come back in Jenkins to say, hey, that scan failed because of these particular compliance violations. And so we have customers, for example, who will, depending on the nature of the violations, integrate build fails into the CI/CD toolchain. So it would roll those changes back in that case. So I hope that answers the question. If not, if you want to ping us after this, I'm happy to drill in and do a workshop on it.
Perfect. We have another question. What are the input streams to Fugue? Are you introspecting via describe events, reading CloudTrail, and/or reading CloudWatch events?
Yeah, so it mostly describes. Not everything in AWS uses the describe nomenclature, but we are actually going and hitting those APIs. We will be integrating some event-driven stuff in the future. What we learned was the event-driven services from AWS can be very eventually consistent, and we wanted the ability to go fast. So we've seen things not hit those event notification streams for 15 or even 30 minutes or longer. That's not fast enough for us. So we want the ability to go. I had that one environment, the self-healing environment, set at 10 minutes. It's also very important for us to be able to, within a couple of minutes from an API call, resurvey an environment. So we're using mostly things like describe calls now, but we are looking at incorporating some of the event-driven stuff as well.
Perfect. And I think you answered this next one. Does it matter how I deploy my infrastructure if I use CloudFormation or Terraform?
No, not at all. And that's one of the reasons we took this approach is even within individual customers of ours, and when I was at AWS customers, very often if you look at the brownfield, and the brownfield is, you know, something you need to address, right? A lot of it was done using different techniques over time, using different tools over time. So Fugue is designed to be totally agnostic about how you've provisioned things. You can be using Terraform or CloudFormation. You can have stuff that was built, again, using Bodo scripts or Java code with the Java AWS SDK. We don't care at all. We're looking at the in situ cloud services and operating from there.
Perfect. And another one is we've implemented guardrails to keep developers from making mistakes, and developers don't have access to the AWS console. You mentioned that this was not a great approach. Could you talk a little bit more about that?
Yeah, so, I mean, there are certain circumstances. I mean, I've worked in environments where that might be appropriate in really high sensitivity national security kind of environments or things like that, where speed matters, speed and innovation matter far less than safety. But that's what you're choosing to do when you do that. And let me describe the process of learning as a developer is by doing. Right, so Fugue went from, we've been around for a few years. Earlier in our existence, we were using things like EC2 instances and containers. And now the back end of most of what I'm showing you is all Lambda functions. We massively cut our costs. We massively improved our ability to scale. Now, if we had cut off console access, all that experimentation to learn those new services, to really get good at them, to understand them, to become capable with them, was done at the console, right? You don't want to start doing infrastructure as code until you know what code you should write. You need to be able to experiment. And I think that this is a critical, I would argue the most powerful thing about the cloud is you now have instant access to brilliant new services that in years past, pre-cloud, you would have to build out whole data center environments to support machine learning as a service. So if you cut off console access and you put hard guardrails around your developers and say, no, just use EC2, you are missing out on what your competitors are taking advantage of. And I think that the trick is to be able to give your developers freedom, but give them feedback on what's allowed and not allowed. And what we're doing at Fugue is we're constantly looking at these new services and telling you which ones are safe in what configurations. So you can lean on us a bit rather than just telling your developers to pretend like they're in a remote data center, which is often what that ends up looking like.
Perfect. And another question. So, and I believe this pertains directly to Fugue product. For companies with AWS organizations with many AWS accounts in multiple regions, can they be onboarded easily, or are regions and accounts added one at a time?
So cloud environments, I'm showing these environments, they are pointed at, right now, single accounts in regions. However, it is very common when customers adopt Fugue, you can write I'll show it to you. I'm going to show you all the code you need to automate inclusion of a new collection of infrastructure automatically into a Fugue environment. And I'm showing you my code editor now. On the left-hand side is a JSON file that says point at AWS US West 2, and here's a role ARN. We operate through IAM role ARNs that you share with us. And we're not going to do remediation. And let's include all of these resource types and go make a new Fugue environment. That's this little script over here. This is just a shell script. The point I'm trying to make is it's really easy to add these environments. And so I'm showing 4 on this screen. It's common for our customers to have dozens or more of these and to have it completely automated into their tool chain. So I don't think it's an either or. I hope that answered the question. Yes.
Yeah, thank you. And I think that's about it. There's one other question about, this is the last one. How can we get the compliance team to embrace a programmatic approach to infrastructure compliance?
Get the compliance team to. So in my experience, and I've worked a lot with compliance teams because I mentioned I used to work in national security. We had to go through ATO processes, authority to operate processes with CNA, certification and accreditation, which is an audit function. The compliance folks are looking for help, right? They don't want to have to manually, with an Excel spreadsheet or some other manual kind of editing tool, go through all of these controls that Fugue covers. So if you can give them with Fugue this ability to say, for this list of NIST controls, we can just automate the answer to that. That's a huge win for them. And it's also a huge win for the development team, particularly if you try to go in and assert security and compliance after the fact. And again, I'll use the security bots as the example of a bad way to do this. You are going to engender bad feelings from the application developers and DevOps. That is going to happen. And the reason is you don't have an agreement. You don't have a contract. You don't have a baseline. All good relationships are based on a mutual understanding and trust. And so by shifting left here, where this environment is not doing any enforcement, right? It's not baselining. It's not going out and changing things. It's just telling the developers really early on what they're going to be told no to later, so they can fix it ahead of time. That gives them the tools to buy into this as well, because it's non-invasive.
Perfect. That is that appears to be all the questions that we have. So Sivia, I will turn it back over to you.
Thank you, Ricardo. Thank you, Josh. Thank you, everybody, for viewing this webinar live. I just wanted to let you know within the next 24 hours, we will have an on-demand version online, and we'll send you the link for that. And if you have any questions whatsoever, feel free in your invitations. You have my email address. You can feel free to send them to me. Anything that we didn't get through to today, and I will be happy to pass them through to Josh and Ricardo. Again, thank you for your time and your attention, and we'll look forward to seeing you in the cloud.